Hi, trig folks. Welcome to 2.2 Law of Cosines. In 2.1, which you hopefully completed already, we dealt with cases 1 and 2. Case 1, when you have one side and two angles when you're given of a triangle. Case 2 is two sides and the opposite angle. But case 3, we're going to cover with law of cosine. So case 3, which I just took one of the problems and we'll finish this in a little bit. Um, Number 2, it's given that you have these two sides, c equals 6, b equals 4, and you're also given the angle sandwiched in between them, angle A, which is 30 degrees. So we're going to use the law of cosines to solve this triangle. And I think rather than show you the proof right away of the law of cosines, I'm just going to show you this example since we've got it pulled up. So in order to do this, this is the law of cosines. We have these three things. Now, I tell my students, there's no point in memorizing the A, B, and C. Basically, the way that I think about it is whatever angle you want to find and whatever sides you know. So we know this and we know C and B. So we're going to work with that and we're going to find this angle, in this case A. But basically, this is side A. And so this is side A right here. So if I set it up, I'm going to say that A squared is equal to. Now, what I was saying or trying to say is that the other two sides, whatever you're given, are the sides that you're going to square on the right-hand side. So this is the side that you want to find. And the other cool thing about this is it's going to be the cosine, because this is law of cosines, right? So it's going to be the cosine of the angle that's associated with this side, okay? And then the way that I remember this, and I don't have to memorize it, is that I just use the other two sides and I square them. So it's 6 squared plus 4 squared, doesn't matter what order, minus, and it should be 2bc, so 2, but I'm just going to square, not square, but multiply 6 and 4 together. So that's the pattern. Let me go over that again because I think it's really important when you set this up. It makes it so you don't really have to memorize too much of the formula in all the three different cases because that can get confusing in my opinion. Side A is the side that you want to find, right? That's the missing side, okay? That means that you need to know the angle that's opposite that side. This angle is given, okay? And cosine of this angle is what you're going to be dealing with, not cosine of any other angle here. That's the one that you know. So that's the connection there. The other two sides that you're given, those are the two sides that you square on the right-hand side. So you take 6 squared and you take 4 squared. Then you subtract 2, don't forget that 2, times the product of the two sides that are given, 6 and 4, times, all of this is multiplication, cosine of 30. Okay, and then you can solve this and simplify. So basically, A is going to equal, now we wouldn't use plus or minus, but the square root of 6 squared plus 4 squared, and we can clean up this part. I guess I could have cleaned that up too, but I'm going to leave it like that. So 2 times 6 is 12, 12 times 4 is 48, so it's minus 48 cosine of 30. So we're going to type this into our calculators, and once again, I always like to do it all at once because it's so much more accurate. You could just do 36 because that's 6 squared plus 16 minus, don't forget to put parentheses around everything that's on the inside, minus 48, and we should be in degree mode still, cosine 30, close those parentheses, and then close the parentheses to show that you're done with the square root. And it's going to give you, so that tells me that A is approximately 3.22, I believe. Yeah, we'll say 3.23. So it's 3.23. So that's this side right here, 3.23. But just like any other triangle, when we're solving a triangle, we need to find every part, all the angles and all the sides. So we still do need to find angle A, whoops, we're given angle A, angle B, and angle C. Okay, and the way that we're going to do that and find angle A or B, you can choose whatever one you want. So once again, the book, and you should read the book because you might like the way the book does it. And maybe I'll do another example with the book, but I like it just setting it up, find angle B, because I find it confusing to like try to keep all of these straight with what is what. But if you're dealing with angle B, the side that you're dealing with, if you want to find angle B, then the side that's associated with that across from it is 4. Okay, so you set that side and you square it and you say 4 squared, okay, is equal to, because we're going to try to find angle B. So over here, I'm going to have cosine of B. All right. Now, what are the other two sides that you haven't worked with? Well, it's A and C, but it doesn't even matter. Just you don't even need to write in A and C. I would just write in 6 squared because that's C. A is plus 3.23 squared, right? And then it's minus 2, 6 and 3.23. So 6 and 3.23. Do you see how I think that this is easier to set it up? Because you know that once again, these two, this angle and this side correspond to each other. So the thing that goes on the left by itself is the side that corresponds to the angle that you're taking cosine of. Everything else gets put here. So the other two sides go here, and then the product of those two times 2, and then it's a minus cosine. So do you see how there's less memorizing, in my opinion, with that? I like that. The hardest part might be doing the algebra, so maybe that's why they decided to um, keep it in terms of A, B, and C when they solved for it, but I don't think that's the end of the world. So you have the 4 squared. I'm trying to isolate the cosine B. So 4 squared minus 6 squared minus 3.23 squared equals negative 2 times 6 times 3.23 cosine B. Do you see how I'm lazy and I don't bother to simplify until the very end? I think it's kind of nice. So remember, we're trying to get cosine B by itself and then we can apply the inverse. So now I'm going to divide both sides by this stuff. So negative 2 times 6 times 3.23. And then over here, negative 2 times 6 times 3.23. Those cancel, those cancel. Now you're left with cosine B equaling all of this stuff. I don't even think I'm going to write it again so you guys see the point. Now we're just going to put that into our calculator, okay? So I can do that. So this stuff here. So let's get our calculators out and we're going to hit the inverse. Remember what I said earlier, whenever you're trying to find an angle, you use the cosine inverse. And you'll see when you take pre-calculus why we do that. So I'm going to put parentheses on the top, double parentheses for the entire cosine inverse and for the top of the fraction. And I'm going to just hit 4 squared. You could hit 16, yes, minus 6 squared, but I said I'm lazy. Minus 3.23 squared. And then I'm going to close the parentheses for the top. And then I'm going to divide by, put parentheses again, because if you don't, it'll just think it's the first thing. So negative 2 times 6 times 3.23. Close those parentheses up. And then close parentheses for the entire cosine. And we have 38.26 degrees. That's going to be B. So we can say that B is equal to 38.26 degrees. Okay, so we know B, we're given A already, so we can easily find C. So this, we're going to fill in our triangle, 38.26. And if we do a little subtraction, we've got 38 and 0.26 and 30 is 68.26. So let's see if I can do some math here. We're going to subtract 180 degrees in a triangle, right? What would that be? What do we have to do to get to that? That's 100. We've got 100 and you guys are hearing me think out loud. What is that? 111.74 degrees. There we go. So I had to pause the video to do a little math on the side. It's bad because usually when I teach a live class, I have students that are helping me with this kind of math right on the fly. So we solve this triangle, and once again, this is the case where you have an angle and then the two sides sandwiching that angle. So we're going to review the proof. And if you haven't looked at this over in the book, I highly recommend you going there before you continue on with this video. I always recommend that you read the section first and then watch the video. I know that this textbook is kind of wordy. It's probably it's got a high academic level, definitely. It kind of assumes that you do have a strong math knowledge. I think it's still good, plus the videos. I hope that that combination is okay. And always remember that there's the Khan Academy and other resources out there if this video isn't enough. And of course, talking with me, one of the most, and your fellow students. So let's go over this proof. The first thing is just from the diagram, because remember you have to consider um, all the types of oblique triangles. So with the acute triangle, and they're using the Pythagorean theorem there. So they have, with this, if this side right here is x, then this would be c minus x because the entire side of this is c. So we're going to do c minus x squared plus h squared equals b squared. And with this triangle, we're going to say that x squared plus h squared equals a squared, because you can see the right triangles right here. These are my two legs, h and x. If you solve for h squared in this triangle, you have a squared minus x squared, and I'm going to go with what the book uses. That's 212. And if you just leave this like as is, this is 2.1.3. So we're going to take it to equation 213, and I'm going to say b squared, and I'm going to substitute because it's h squared plus c minus x, oops, sorry, that's sloppy, squared, and I'm going to put in h squared, which is equivalency to a squared minus x squared. So I'm going to substitute a squared minus x squared plus c minus x squared. And if I expand that, I have to FOIL this out, so it's b squared minus a squared minus x squared plus, remember that's c minus x times c minus x. So that's plus c squared minus 2cx plus x squared. Now you can see that the x squareds cancel out, and if you clean this up, you're left, with b squared is equal to a squared plus c squared. We're getting somewhere, right? It's starting to look close. 2cx. Okay, so in the case of the acute triangle, we can use the idea that the cosine of b is equal to adjacent, which is x, over a. Do you see that? Here's the angle. Here's my right triangle. So the cosine of this angle is adjacent leg over hypotenuse, which is a. That means that x is equal to a cosine b. And in the case of the obtuse triangle, we can say that the cosine of 180 minus b is equal to adjacent, which is x, over a, and that implies that that is a cosine of 180 minus b, running out of room, is equal to x. So for the case of the acute triangle, because remember this is for the acute triangle here, we know that x is equal to a cosine b. So I'm going to substitute that into this equation for x. So now I have the law of cosines for one of the sides, a squared, and one of the angles, c squared minus 2c, and then it's a cosine b. And I actually need to backtrack because I'm just realizing that that I've only shown you for the case of the acute triangle. So it's really important that we look at c minus x is actually using this triangle here, because this x could be something completely different. So they show that step. It's on page 45 in your book for the obtuse triangle, and it's very similar, so I'm just going to stick with the acute argument. So this and this are both related to the acute triangle. So this is for the acute triangle. You'll use this fact when you get to the obtuse triangle when you read through it. So remember case 1 and case 2, both from 2.1, Law of Cosines. Case 3, two sides and an angle between them. This is what we just did, 2.2 in that example. That was number 2. Now if we're looking at something with 3 sides only, that's case 4. So this is also 2.2. We're going to use the law of cosines. Just a quick thing though, before you go through all that work, you might get a case like no solution, which you may have gotten in 2.1 as well. Sometimes it's just these 3 sides won't make a triangle, and what I would do is I would just make sure that the sum of the 2 small sides, so we have 11 plus 13, you want to make sure that that is greater than, that it's greater than the other side, so 16. And this is definitely going to make a triangle, okay? So what we're going to do is we're going to set up what we know. First, I would just draw the triangle. I think it's so much easier. And we don't know any of the vertices, so we're just going to say A, B, and C. And then if it's given that A is equal to 11, that's opposite angle A. B is opposite angle, or the side B is opposite angle B, and C is over here, 16. Okay, so find whatever angle you want to find. Remember, let's just start with A. So if we are going to find angle A, that means I'm dealing with cosine of A, and I'm dealing with 11, and I'm going to square it. So it's 11 squared. Okay, then you square the other 2 sides. So 13 squared plus 16 squared minus 2. A is 13, C is 16, cosine of A is our unknown. Okay, so then what I do after that is I just simplify as is. So I've got 11 squared minus 13 squared minus 16 squared, I'm bringing it over, equals negative 2 times 13 times 16 cosine. See how lazy I am, A. And then I'm just going to bring this stuff right here over to the other side in the denominator. So now I have 11 squared minus 13 squared minus 16 squared divided by negative 2 times 13 times 16 equals cosine of A. Now, you once again need to find the angle. So what function are you going to use? Are you going to use the cosine function? No, you're going to use the inverse. We're going to use inverse cosine. So let's get our calculators out and do that. So I'm going to have, let's clear it out, second cosine inverse. And I'm going to put all of this in parentheses. So I have 11 squared minus 13 squared minus 16 squared. I'm going to close the parentheses for the top. I'm going to do the division sign, parentheses on the bottom, negative 2 times 13 times 16, close the parentheses for the bottom, close the parentheses for the entire function, and I get that A is equal to 43.05 degrees. 43.05 degrees. Okay, so we still need to find one more angle because that's not going to give us enough to solve this triangle. So this angle right here is 43.05 degrees, and we're going to do the same kind of setup. So I'll set it up and we'll get the answer. It doesn't matter which one you use. Oh, you know what? You don't even need to. I was just going to say you can do the same similar thing. Um, it's actually, in my opinion, just as easy to do that. So I think I'll just do that again. So this time I'm going to use C uh, and I'm going to use 16. Now, in the book, they talk about using the law of sines at this point, which you could do. But remember how the law of sines can have, if it's an acute angle, the case can be ambiguous. It could be an obtuse angle or it could be another angle under 90 degrees. And so it's just safest to use the law of cosines because the complement of the angle that's given isn't going to be negative. So you have those two choices. You could do sine, but then you might get two cases, but cosine is always safe. So you don't have ambiguous cases with cosine. So if we do that, remember I have the 16, that's my C. So remember that's C squared. And then the angle I want to find is cosine of C. So this is what I set it up. This is how I set it up first. Then I just put the other two sides that I'm given. So I have 13 squared plus 11 squared minus 2 times 13 and 11. Isn't that cool? You don't need to memorize all three of those cases. You just need to memorize this kind of setup, okay? And then you can solve for cosine C just like we did. Can we take a guess and see what it would be? All in one step. I bet it's cosine of C is equal to, can you guys guess? 16 minus 13 squared minus 11 squared all over negative 2 times 13. This is just algebra. I'm just solving times 11. And if we plug this into our trusty calculators, let's see what we get. And you know, what I'm thinking is that actually, have you ever used the second enter, which gives you the entry again? I don't know if it'll be more work, but you can just kind of change the number. So what did I forget? Oh, big deal, guys. I forgot the 16 squared. I knew something was wrong. So don't forget that 16 squared right there. Okay, that's really important. All the sides are squared. So it should be, let's see, 16. So I'm going to change that to a 16 minus 13 squared minus, so now I'm scrolling over to minus 11 squared, right? Minus 2 times 13 times, scroll over, 11. I think I did it all correctly, right? Let's hit drum roll, please. 83.17 degrees, okay? So using inverse again. So that tells me that angle C is equal to 83.17 degrees. So that is this angle right here. And now I know that 180 degrees gives me the total. So let's just do it on the calculator this time because nobody's helping me. So we've got 180 minus 83.17. minus 43.05. And what does that give me for angle B? Angle B is 53.33 degrees. Okay, so that is 53.33 degrees. So we solved that triangle we were given. It was case 4. We were given all the three sides and we found the angles using the law of cosines. So I think I'm being too easy with you guys, and I'm always drawing the diagrams without letting you think about it first. I'll revisit these, and also you have a chance to open up the discussion in the Q&A forum. And one of our students, he actually attached a file, just his drawing on the Q&A, which I would highly recommend, and I want you guys to do that as well. Just a little quick algebra review with number 8. Two trains, it's a classic. Leave the same train station at the same time. You're going to have to use that idea. Just rate times time is equal to distance. Okay, so you know that the rate of one train is 100 miles per hour at average speed, and the other at an average speed of 90 miles per hour. So I'll just give this idea. So we have one train is rate is 100 miles per hour times 1/2, and I'm doing the hours on the top because they travel for a half an hour. There's hours, boom, boom, cross that off. That gives you 50 miles that that train has traveled. That's just rate times time times time times distance. Okay, this is R, this is T, this is D. Okay, so draw the pictures in number 7 and number 9. Try to share with other students. See how you do. Come visit me during office hours and do the doodle poll if you haven't. I really want to see if I can get more students involved on the live lectures. It's really nice to have your feedback. Come see me. Okay, I'll see you around.